All right, attempt number 2. So this is lesson 7. Sorry, I know I already said this, but I want it on the recording. So a scatter plot is what we just did. It's an XY axis, has a whole bunch of dots. There might be a pattern to the dots, there might not be a pattern to the dots. So positive correlation, everybody grab your pencil if you didn't do it before, and I want you to draw a line that you think is a good representation of the graph, something like that, okay? Negative correlation, so these were all the random things I was drawing as I was trying to see. Now they're all there, right? Okay. Negative correlation, grab your pencil, guys, draw a line, maybe something like that, okay? There can be wrong lines. Here's an example of a line that is not a good line, okay? Look at this. Some people will be like, well, that's the trend that's happening, and I know it's good because I hit 2 of the points. Are those going flat, guys? No. So that's not a good line. They're going down. Okay. This one right here, there's no correlation between those points. I can't draw a line that hits it. They're just all over the place. So, you know, there's no correlation. Okay, right here. Line of best fit, that's kind of what we just talked about. So draw a line that you think best hits it. Like I said before, there's a lot of right answers. You won't all choose the same points to go through, okay? And then there's another example of line of best fit. Okay, look at example 1. This is a poor choice. Okay, so what's happening? Look at this one right here, question A. You guys, it's increasing faster than what that is. So when you draw your line, make sure you don't draw it like question A. You've got to show that those points are going up and they're going up steeper than what we've got right there, okay? So grab your pencil, and a good example might be something like, you know what I try to do, guys, is I'm like, okay, I'm going to try to hit that dot and that dot because I feel like that's going to be a pretty good representation. And then I go like that, and then I look at the dot, and you know, I look at my line, and I'm like, yeah, those are, you know, that's pretty good. So what was wrong with that one, you guys, is that it really wasn't steep enough. Okay, so that's a way better line. Okay, look at question B. We already talked about that. Are the lines going horizontal? No, they're not. So grab your pencil. Just kind of eyeball it, you guys. Like, I'm going to choose this point and this point to go through. Okay, you don't have to be the same as me. Your line just has to be good. So grab your pencil, connect 2 dots that you think would be a good representation, and it looks something like that. That's called a line of best fit. Okay, so here's how you determine the equation. There's several different ways, but draw the line of best fit, write down the 2 ordered pairs, figure out the slope, look at the graph and see where it hits the y-axis or the vertical axis, stick it in as your B, and you've got it. Okay, so let's go ahead and do it. Everybody grab your pencil. If you want to grab something like a piece of paper or something to connect the dots, then that's great. But grab your pencil, and I want you to draw a line. Please don't copy my line. Your line can be whatever you want, whatever you think is a good line. It does need to be a straight line. Okay. Now that you have your line, I want you to write down 2 ordered pairs that go through your line. It may not be the same as mine. Actually, you know what? Let's do it the same. Let's do it the same. So this one right here, it almost looks like 1. It's a little bit more than 1. I'm going to guess that that is 1.2. You'll never really guess anything in this class, and except a line of best fit is an approximation, so that's why we're doing it. And it's up like 1, 2, 3, 4, and a little bit, so maybe like 4.25. Okay, hopefully you'd be given these points so then you don't have to estimate. The next one, 1, 2, 3, 4, 5, 6, 7, maybe 7 1/4, so 7.25, bless you. And then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, about 17. Okay. So I just want you to do mine so it's the same, so we have the same answer. Okay, so everybody go, M equals 17 minus 4.25 over 7.25 minus 1.2. Okay, now maybe you wouldn't say 1.2, maybe you say 1.25. It doesn't matter. This is an estimation, so it doesn't have to be perfectly the same as everybody else's, okay? So, grab your calculator. If your calculator's not on your desk, guys, always just automatically put it out every day, so then we don't have to sit and wait to grab it, okay? So everybody go 17 minus 4.25, and on the top, you get 12.75. On the bottom, 7.25 minus 1.2, that gives you 6.05. I want you to write it as a decimal, okay? So everybody go 12.75 divided by 6.05, and you get 2.1, okay? So now remember, your equation is y equals mx plus b. M is the slope. So it would be y equals 2.1, and then b is right here, guys, this green dot. It's where it touches your y-axis, and you can see that it touches at a 2. So I'm going to go 2.1x plus 2. There's my answer. Okay. Now I'm going to tell you right now, when I grade this, here's what I do. I say, okay, the slope I have right here is 2.1. So I'm going to accept anything from 1.5 to 2.5. If you're lower than 1.5 or bigger than 2.5, then I'm going to dock a little for the slope. So we've got a little range that's acceptable. This y-intercept is 2, so I'm going to accept anything from 1.5 to 2.5. Anything out of that boundaries, they're going to lose a little bit of points for the y-intercept. So that's how I do it. I just kind of give myself a range, okay? Okay, everybody look at question B. Now let's do this one differently, okay? So you choose your own points, and you make your own line. So when I say differently, I mean different from me. Okay, there's my line. Look up and compare your line to my line. It doesn't have to be the same, but it needs to be close. Okay, now I want you to write down those ordered pairs, you guys. Okay, now you have your point. Let's do the slope. So you use the slope formula. Make sure you put the y's on the top and the x's on the bottom. Then I want you to figure out the top number, the bottom number, and then I want you to divide. So get an actual number, okay? And again, mine's going to be different than yours, and that's okay. Once you get the slope, I want you to stop, okay? Who says, I'm there, I've got my slope for my line. Do a big raise up so I can see how to do it. Okay, we're going to wait for like 30 seconds. Okay, so I got negative 2.1. I want you to look at what you got. If your number is anywhere from about negative 1.5 to negative 2.6, then I would give you credit for that. Okay, who says mine was right in that range? Raise your hand. Okay, beautiful. Now I want you to look at your graph and come up with the equation. So put your slope where it goes, look at the graph, figure out the y-intercept. Is that a 20? Is that what you guys counted? Yeah. It's kind of tedious with those small little dots counting, but I got a 20. So anywhere from a 19 to a 21, I would give you credit, okay? And remember that this is an approximation, okay? All right. One last thing. That's literally the lesson, okay? So it's super short. Isn't that nice, right? So cause and effect. Just because one thing goes up causes another thing to go down doesn't always mean that this one caused this one, okay? Here's an example of something that is cause and effect. Everybody listen. The time of day and the temperature outside. True or false? As the time changes, the temperature changes. Don't answer yet. The changing of the day, the changing of the time of day causes the temperature to go up or down. Who says yes, that's true? Raise your hand. Okay, that's cause and effect. The changing of the time, the sun coming up changes the temperature, that's cause and effect. So let's think of something that is not cause and effect. As something goes up, the other thing goes up. Okay, so I've got one. I can't think of one. Someone tell me one. Can you think of one? Make sure it's appropriate. I had somebody one time raise their hand and say something inappropriate when I said this. Thanks, bud.
The mileage of a car is like a function of miles driven.
Okay, the miles. Say it again. The miles.
Okay, the mileage of a car is a function of miles driven.
Like of how many miles I drive today.
Yeah.
So like, let's say, okay, so we could totally make that work. You buy a car from a person that's someone that commuted to Salt Lake every single day. Well, that's going to have high mileage. But now it's your car, and you only go to school and back, and your work is like a mile from your home. So just because the mileage is high, does that cause you then to be driving high mileage? No, because it wasn't your car before. You know what I mean? So good. Just because this is high and this is low, did it cause it? No, but it's correlational. This is always going to be high, this is always going to be low. Okay, good. Anybody else think of anything? Okay, so we're going to stop. That's your whole lesson, like literally.